Okay. So, I'm going to use my numbers. I get 4 over 5 equals 6 over 9. Okay? So how do I solve? Oh, it's not equals times. Okay? Well, now one thing I could do immediately is I could divide the 6 and the 9 each by 3 to get 2/3. Okay? And probably ordinarily that's what you do because you end up with smaller numbers. But just to illustrate the operations without going to that step, and that's a step I think everybody understands. This is just 4 times 6 over 5 times 9, which is 24 over 45. Now, 24 over 45, both of these are divisible by 3. So divide this by 3. And divide the 45 by 3 and you get 8 over 15. And that one doesn't reduce. Okay? Now there's another way to reduce that. Okay, 24 is divisible by 2, leaving you 12. 12 is divisible by 2, which leaves you 6. So 12 could be written as 2 times 6. So this could be written as this. 45 could be written as 3 times 15. And then 2 times 2 times 6 could be written as 2 times 2 times 2 times 3 over 3 times 3 times 5. Okay? It's called prime factorization. Just write these as products of prime numbers, and I hope you know are numbers that can't be divided evenly by other, or can't be divided as integers by other numbers, okay? Then you could write this as three over 3 multiplied by this, okay? And 3 divided by 3 is 1. And that's just 8 over 15. That's something you really want to understand, because when you get to rational functions, okay, a little more than midway through chapter 3 in the open math version, and I'm still sorting out where that is in the Larson version, but it's around the same place in the course, okay? Probably going to encounter it mid to late October, maybe earlier, I don't know, for sure. But it's coming up in a few weeks, maybe about a month or even a little more, I don't know. You need to understand what I just did here. So it'd be worth taking a look again at that part of the video if you understand everything else. And making sure you understand. Okay, so anyhow, A over B. That's going to be 4 over 5, so that's 4 over 5 divided by 6 over 9. Same fraction, but now we're dividing. Now, the reason I wanted you to do the division by fractions, this is 5th grade arithmetic, I'm telling you, okay? If it's 5th grade arithmetic and it's in this course, it's really important that you get it. And it's only a 5th grade level thing. All you got to do is know the rules and practice a little bit. Okay? You're way plenty smart to do that. You're sharper than you were in 5th grade. You know more. You learned it there. Relearn it. Because again, this is, you're going to need it. At the same point in the course I'm talking about. Within probably about a month, give or take a little. First of all, that means 4/5 divided by 6/9. And when you divide by a fraction, you multiply by its reciprocal. Okay? This then equals 36/30. Now you can reduce that. That is both divisible by 6. You're going to get 6/5. Okay? But I'm going to go ahead and do the prime factorization again. 36, you divide by 2, you get 18. You divide that by 2, you get 9. And 9 is 3 times 3. 30 divided by 2 is 15. And 15 is 3 times 5. Incidentally, open math and everything, going to teach you to cancel. I hate cancellation. I absolutely hate it. Because people don't do it right. They cancel wrong. My pre-calculus class, everybody's canceling. Nobody's canceling correctly. Okay? If they are, it's an accident. Because they cancel any time. Okay? They would cancel this 2 with this 2. Well, not that bad. Okay? But some people see 3s and they just cross out all the 3s with numerator and denominator. Then get 8/5. Okay? Stuff like that. You can't be doing algebra like that. Okay? You can't be treating numbers like that. So I factor things out because that's what cancellation is. You can factor out a 3/3, then you got a 1, and those 3's go away. Okay? So here, again, we can factor out a 3/3. And that still leaves you this 3. And of course, that leaves you the 2 and the 5. That equals 1 times 2 times 2 times 3/2 times 5. And 2 times 2 times 3 is 12. And 2 times 5, oh man. I'll fix that. Apparently my eyes just aren't working. Or like in my brain. Can't do it 2/2, right? And that leaves you one of the 2's and one of the 3's over here now. And you're going to have 2 times 3 over. Well, the 2 and the 3 are gone, so that's going to be over just 5. Now, your denominator's 3 times 2 times 5. Your numerator's still 3 times 3 and 2 times 2 as it was, right? You've just rearranged it. You've factored out a 3/3 and a 2/2. So that's 1 times 1, just to re-emphasize, times 2 times 3/5. The 1's don't do anything. And you end up with 6/5. You want to understand every detail and understand why that's equivalent to canceling if you were doing canceling correctly, okay? I think you probably would do canceling correctly on this. But when you get into symbols, when you get into expressions that have like x minus 2's in the denominator and x plus 5's in the numerator and just a bunch of factors, you're going to get very confused if you don't understand how to do this, okay? Now there are rules for cancellation, but nobody ever learns them well. Now when I say nobody, 1 person in 100 comes in my pre-calculus class, really knows how to cancel, okay? Maybe it's 1 in 50. I don't think it's any more than that. Everybody does it wrong. If you write an expression, it tends to trip people up. Okay, so anyhow, there we have it. That's fractions. Now you got to know how to multiply fractions. You got to know how to simplify them, and you got to know how to do prime factorization and all that stuff. Okay? Make sure you do. You'll be glad later. Okay? And you'll be very unhappy later if you don't. Maybe not that unhappy, but one of the big stumbling blocks in pre-calculus is that whole idea that comes out of this. Okay. Now, everybody did fine solving this. I'm not going to do it. Okay? I'll look at your paper and I'll write you a little note if you did something wrong with it. Everybody's doing the right stuff. Okay? So if you tripped up on a little detail, it's not going to help to see me work it through. What I'll do is I'll put a note in your kids. Okay? So we can go to these two and then this one. I'm going to actually take care of this one. It's in very simple. In my case, it would be x squared plus 5x minus 6 equals 0. Okay? Now it turns out I can solve that by factoring, but that's another topic. We'll get to that. And of course, you've got to be able to do the factoring before you get to the place where you apply these ideas here. It's a quadratic equation. It's an ax squared plus bx plus c equals 0. Where a equals 1, b equals 5, and c equals -6. Everybody okay with that? Pretty obvious. Okay? So there's x. Two possible solutions, one corresponding to the plus, one corresponding to the minus. Provided the expression under here isn't 0, there'll be two solutions. Because when you add something that isn't 0, you get something different than when you subtract it. Okay? That's pretty obvious if you want to think it through. Now sometimes your solution is not a real number because you get a negative under this, which leads you to complex numbers. We're not going to talk about that just yet. But it's not hard. Okay? And I learned it in high school, my sophomore year, when I first encountered it. What's the point of that? It turns out that then I spent my last 2 years or 7 years of higher education, graduate years, studying functions to come out of that with the imaginary. It's one of the most powerful parts of mathematics. Okay, well anyhow, you get this. And then that's easy, you just plug in -5 plus or minus the square root of 5 squared minus 4 times 1 times -6, all divided by 2 times 1. Okay. What's that equal? Well, 5 squared, looks like a kind of a monstrous 5, but that's 25, right? And 4 times 1 times 6 is 24. You got a negative here and a negative here, so it's going to be plus 24. So when you simplify this, you get 49. Okay? So I have to come up here to write it. I can write it in 2 steps. That's 5 plus or minus the square root of 49 over 2. Square root of 49 is 7. So this is an unusual case because we actually get an integer. 49 is a perfect square. The numbers most of you would get would not be a perfect square. Okay? So we have to write it as a square root. We'll worry about that later. Well, minus 5 plus 7 is 2. 2 over 2 is 1. And then the minus negative 5 minus 7 is negative 12. Negative 12 over 2 is negative 6. As I say, this can actually be factored. It's x plus 6 times x minus 1 equals 0. So either x plus 6 is 0, which makes x negative 6, or x minus 1 is 0, which makes x 1. So if you kind of remember about factoring, that's fine. If not, get to it, okay? So fairly straightforward to factor that in. Okay, well those are the easy ones. All you have to do is recognize that this is a quadratic equation that can be put into this form, right? And then identify A, B, and C, and plug them into this formula, which you should try to remember. And, you know, by the time you're done with this course, you should have done dozens of these. And by that time, you probably will remember it. Depends on your memory there. But you got to use it in most cases. You got to either factor this or use the formula. Okay? There's another operation to do, completing the square. I'm probably not going to talk about that in this course. Maybe. Okay, now the last two problems. Well, I'm going to break the video here and then we'll do the last two.